There is a moment roughly 2 million years ago that nobody witnessed, but that changed everything. A hominin, not yet fully human, not the knuckle-walking ape of a few million years before, but something in between, something becoming, is standing at the edge of a kill site. The kill was not theirs. A pride of lions took down a large bovid sometime in the previous hour, fed, and moved on, leaving the carcass in the condition that large predator kills leave carcasses. Significantly opened, with the primary organs and large muscle masses consumed, but with substantial remaining material that the lions will not return to in the immediate term. The hominin approaches, not quickly, with the specific, careful assessment of risk that characterizes an intelligent animal moving towards something valuable in a landscape full of things that might want to take it from them. They look at the carcass, they look at the bone, the large dense femur of the bovid, still articulated, still containing something that the lions did not access and cannot efficiently access. And then they do something that a lion cannot do, that a hyena cannot do despite their famous bone-crushing capability at certain scales, that essentially no other animal in this landscape is equipped to do in the specific way this hominin is about to do it. They pick up a rock, and they use it. The marrow comes out. Dense, fatty, calorie-rich marrow. The specific nutritional payload that this specific technology was evolved to access. And the calories in that marrow will, over a long enough timeline of repeated events like this one, contribute to something extraordinary. The growth of a brain that is metabolically expensive beyond almost anything else in the animal kingdom, that requires sustained caloric investment to develop and maintain, and that will eventually produce the species sitting here today watching a video about how it came to exist. Animals did not just coexist with ancient humans, they shaped us in ways that are specific, documented, and genuinely profound. Let's start with the most fundamental and most debated mechanism, the role of animal protein in the expansion of the ancient human brain. The human brain is, by any biological measure, an extraordinary organ. It constitutes approximately 2% of body weight, but consumes approximately 20% of the body's caloric budget at rest. That metabolic cost is staggering. The energy required to run a fully developed human brain is so high that it imposes genuine constraints on every other energetically expensive system in the body. The specific trade-offs that human evolution made to afford the large brain, reduced gut size, reduced muscle mass relative to other primates, specific metabolic efficiency changes, all reflect the specific demand that brain development imposed on the ancient human energy budget. For the brain to grow across the span of hominin evolution, from the approximately 400 cubic centimeter brain of Australopithecus to the approximately 1,400 cubic centimeter brain of modern Homo sapiens, the available caloric supply had to expand correspondingly. The brain did not grow because the caloric supply was already available. The caloric supply had to increase for the brain growth to be sustainable, and the specific caloric expansion that fueled hominin brain growth was, in significant part, animal-derived. The specific nutritional profile that animal products provide: high-quality complete protein, omega-3, and omega-6 fatty acids in the specific ratios required for neural tissue development, bioavailable iron and zinc, and B12, in forms that plant foods cannot efficiently provide, maps almost perfectly onto the specific nutritional requirements of building and maintaining a large brain. The neural tissue that a large brain consists of is primarily fat, specifically specific long-chain fatty acids, including DHA, that are abundant in animal products, and that plant sources provide only in precursor forms that the body must convert with limited efficiency. The expansion of animal product consumption in the hominin diet, the shift from a primarily herbivorous diet toward the omnivorous, animal-heavy diet that archaeological evidence documents in Homo habilis and especially in Homo erectus, is directly correlated in the fossil record with the acceleration of brain growth. The causal relationship is not perfectly established. Correlation is not causation in evolutionary biology any more than elsewhere. But the nutritional logic is compelling, and the temporal correlation is striking. Animals, by being food, fueled the brain that eventually thought about what animals were for. Let's talk about the specific technology that access to animal resources drove, because this is where the evolutionary feedback loop gets interesting. The Oldowan stone tools found at sites dating to approximately 2.6 to 2.5 million years ago, the oldest confirmed stone tools in the archaeological record, were used in significant part for processing animal carcasses. The specific wear patterns on Oldowan tools and the specific cut marks on animal bones found at Oldowan sites tell a consistent story. Ancient hominins were using stone tools to access the flesh and marrow of large animals that they were either hunting or scavenging. Here is the evolutionary feedback loop that this establishes.